In the 21st century, there is no doubt that the world is facing the environmental challenge of climate change that has already started its impact on the ecosystem. Greenhouse gas emissions play a crucial role in all global environmental issues. Carbon dioxide is one of the major causes of climate change and corresponds to approximately 3/4 of total greenhouse gases in the atmosphere. Among other greenhouse gases, carbon dioxide is the single largest contributor to global warming. CO2 emissions mainly come from both natural and anthropogenic sources. Reaching zero carbon emissions by 2050 requires rapid actions in both carbon emission reductions from the large point-emitting sources, applying carbon capture, and switching to sustainable energy systems step by step. Therefore, there are mainly three options to mitigate climate change by minimizing carbon emissions. First, discontinue the use of fossil fuels and completely switch to renewable energy. Second, continue the use of fossil fuels and completely embrace carbon capture, utilization, and storage technologies. And the last option is that, continue the use of fossil fuels and a combination of embracing carbon capture, utilization, and storage technologies and using renewable energy. Carbon capture and storage and carbon capture and utilization is assessed as a promising strategy to mitigate climate change by decreasing the atmospheric concentration of carbon dioxide from both power and industrial points. Carbon capture and storage is the separation and capture of carbon dioxide from the emissions of industrial processes and storage in deep underground geologic formations. Carbon utilization is an industrial process that makes an economically valuable product using carbon dioxide. Generally, pre-combustion, oxy-fuel combustion, and post-combustion are primarily three approaches in the separation of carbon dioxide. There are several post-combustion technologies to capture carbon dioxide from flue gases involving absorption, adsorption, membrane separation, cryogenic separation, and calcium looping. Absorption-based carbon capture relies on the principle that carbon dioxide in the flue gas is transferred into the liquid phase by selective absorption in a solvent. Adsorption process is a chemical or physical process where molecules, atoms, or ions are captured by the solid adsorbent. Membrane separation process is a process that uses a special module called a membrane to separate gases in a gas stream by rejecting contaminants and passing the others through the membrane module. Cryogenic carbon capture involves a physical separation process based on the differences between the boiling and the desublimation points of carbon dioxide in the gas mixture. A calcium looping system is a carbon capture system that can be easily retrofitted into the power and industrial sectors. In this system, solid calcium oxide-based sorbent is used to remove carbon from flue gases and to regenerate back the solid sorbent.